Here is, what is this, number 4? Yeah, homework problem number 4. Shaft CD is made from 66 diameter rod and is connected to a 48 millimeter diameter rod, shaft AB as shown. Considering only stresses due to twisting and knowing that the allowable stress is 62 megapascal for each shaft, determine the largest torque that can be applied. Okay, so we have this equation here that, let's see, the brush button, oh, app, brush button, that T, torque, is going to be equal to the allowable shearing stress, so this allowable times J over C. But we also know that J is equal to pi over 2 C to the 4th. So T is going to be equal to the allowable stress times pi over 2 times C to the 3rd. And we can use this for rod or shaft 1 and for shaft 2, but we can call them shaft AB and shaft CD. So for shaft AB, the torque is going to be equal to, well, it's the same allowable shearing stress for both, 62 mega. What's mega? Let's open my calculator and apps, science tools, unit converter, science prefixes, or SI prefixes. Mega, 1 mega to base, is times 10 to the 6th. Times 10 to the 6th. So that's good. Now, pi over 2. And then J, or actually not even J, we just need C. So what's this? Shaft AB is 48. Right here, 48. What's an 80 millimeter? Well, that's fine. We don't worry about what that is. Or do we? We need the gearing ratio? Not yet. Not yet. So then C cubed is going to be 48 over 2. 48 divided by 2 is 24. 24 cubed. So TAB is, let's see, 62 times 10 to the 6 times pi over 2 times 20 millimeter times 24 times 10 to the negative 3rd to the 3rd. I'm getting 1346 tension is going to be kips. I don't know, so I won't write it. Torque. We've got, let's look at our units. Meters and Pascal. Pascal meters? That doesn't make any sense. So I won't write nothing right now. It's going to be Newton meters at the end. I'm assuming the torque is going to be Newton meters right now, as is. But I won't write nothing. And now let's do the same thing for shaft BC, or CD, right? CD. Except I'll just write TCD because we already know the basic equation here. And the only difference is the shearing stress is the same, pi over 2 is the same. The only difference is C is going to be 66, which is 33, because we're taking half of the diameter. And this is going to equal 34.99 actually. Much better. I guess that's much thicker. Who would have thought? Okay, gearing ratio. Wait, we have TAB and TCD. I guess it's asking the largest of the two. So now let's look at the gearing ratio. We have gear C and gear B. So R. Yeah, R. R of C. And then T, C, D go on top. And this is going to be equal to R of B, T of AB. So we have 240 over right, yeah, 240 over 80 equals 1346, 3489. Well, let's see if that's right. This divided by this. Okay. 240 divided by 80. Close. So we actually, what are we trying to find? Large torque. Torque. There's some wiggle room. So, how do we get? This is 3. Okay, 3. How do we make this equal to 3? Well, if I make the bottom one smaller, we get closer to 3. So what I could say is that we don't know what this is. So we're going to call this tension, just T. I'm going to label this TAB. There's only one T here. So now, if I just take 34.99 and divide that by 3, I'm getting 1166.62 is equal to T, which this is our largest torque that can be applied by our ratio of our gears that we have here. Boom.